Uh, Continuing, Jinsan and Narmada will be talking about uh, testing big data application without ETL. In this talk, the presenters are going to be is going to walk through about the general practices of ETL and then explain how it can be achieved without ETL. They will be even touch basing on the Azure Databricks and PySpark. A little about the speakers. Jinsan is a senior consultant of Thoughtworks, having an overall experience of 13 plus years. He's worked on multiple domains, tools, and technologies, prominently in the field of big data, AI, and ML. Narmada is a solution-based quality analyst with about 8 plus years of experience. She has been very keen on exploring tools and technologies, including big data, mobile API, and performance. Over to you.
Very good morning to everyone. Thank you so much for coming here today to attend this talk on a Saturday. So today's topic is what we'll be talking on is testing big data applications without ETL. So before we get into the testing part of it, we'll also explain what is a big data application, how does it work with ETL and without it, so that you have a clear understanding and you have some takeaways also at the end of it, even if it is new for you. Okay, so we'll take a simple use case so that everyone can relate to it. So just imagine that your application is a payroll calculating application, and you have to calculate the payroll for around 10 lakh plus employees. Okay, this is your use case. And if for such a scenario, you can think about what kind of inputs you would first require, right? So you would definitely require the number of working days, say the timesheet which you are submitting at the end of the week, say the public holidays of that organization, the calendar holidays, your pay scale details, your tax return details, and all such things would be the input which is required to calculate your payroll. And your application is going to calculate this. And one thing to note about this is all of this data is not going to be coming from a single data source. Like it's not that one team is giving it to you at the same time, all of it is coming to you. So if you think about it in terms of files, say it would be something like this. So you can imagine this as your feed files. So say, let's say employee pay scale, timesheet, and all these other different files which will be generated by different teams, and they will be dropped in one location for your application to consume. So the first thing to do for you is to collect these different data sets from different teams and then process these information as per your formulas, right? So how does this application work? Simple data architecture diagram for this. So all of those feed files, say we will be putting it in a file storage location. And all these different teams like your HR team, your finance team, your tax team, and all reimbursement teams, all of them will be dropping their files in the file storage location. And they will be doing it at different times. So first thing to do is to extract this data from these files. And this extraction, it's not going to, you have to first define when you want to extract it. You can define rules like extract it as soon as a new feed is dropped or extract it in timely fashion, right? So all such kind of rules is going to be there in your extract stage. Next is going to be your transform stage, where all of this data is going to be transformed into certain structures which is required to be stored in your databases. And also if you would have data which is redundant or which is duplicate, or you would also say, for example, your employee ID cannot be null, right? All such kind of rules will be written in your transform stage. Any issues with the feed files, whatever you don't want to process, right? All of that you will take care in your transform stage. You will set up rules in the transform stage, and you will do that in the transform stage. After your transform stage will be your load stage, where all of this transform data will be loaded into a relational database, which is tied to your application. So what we did is all the data which we have in the file storage is now going through an ETL process. And now you have data available and you have a application to process this data to calculate your payroll. So this is how a traditional ETL model works with a big data application. Now, this might work if your data volume is not very large. Once your data volume is too large, it becomes more voluminous and the velocity with which the feed is getting dropped is say higher, then this kind of a model would not work because we have a lot of complexities in ETL. So the first thing is it's a very sequential process, right? So only after your extract stage, your transform can run. And only after your transform, your load is going to run. And your application is going to process only on a successful ETL. So during your transform stage, just imagine that one of the teams made a mistake and there's an issue with the feed file, which was not taken care in your transform. You didn't have a rule set up to handle such a complex data. So at that time, your transform stage is going to fail and you would have to manually fix that error and re-trigger your ETL. So you're losing a lot of time in this process. But if you take our use case, you cannot, you have to process the payroll at a certain time. You cannot process the numbers at a later time. It's not acceptable, right? Accuracy is also very important. So such kind of a system would not work in this setup. So what we will recommend is consider this architecture where my input feed is my major factor and it is an external storage. And my application is doing all my data processing and computation and then just giving me the result set. So am I just asking you to put all your CSVs in a cloud storage? No. So what we're saying is you have file formats like Parquet, Delta, or ORC, which is a column-oriented storage process. Your CSV is like a row-based storage system where you store your data per row. For example, if you have name, ID, age, in your CSV, you would say name 1, ID 1, age 1, and you would store it like that. But a Parquet stores it in a column-oriented fashion. What would happen is you would store as name 1, 1, 2, 3, 4, ID 1, 2, 3, 4. This is not a human readable format. It'll be a compressed way of storing your data. It has various encoding schemas which can be implemented. And you will be using processing engines like Apache Spark, which can process the data from these Parquet files. And then your application can work on it. These are just some example tools. We're not recommending or telling about any tool in particular. We're just giving an example of how this architecture works. So if you look at it, what is important is this storage, this data which is stored, right, which is the main essence of your big data application. So if you see how the cloud storage providers charge you, like Google and Amazon would charge you based on the amount of data you store. Whereas Spectrum would charge you based on the data scanned, and Dataproc would charge you based on time. So for all such cases, if you go with a Parquet file, you would see there's around 99% saving because it would require very less storage. And also Parquet has data skipping. What it means is you don't have to query a single row or to update a single row. You don't have to read all the rows in the file. You can just pick that particular value directly using data skipping. And you would just, so hence your runtime and your data scan will be significantly reduced. So this gives you around 99% savings. So we've just put up a small code snippet to help you understand how data processing works in this setup. So this is an example of Azure Databricks notebook. Azure Databricks is not open source. So I've just kept a file in my in the file location, a DBFS layer of a Databricks. And if you see, I'm just reading that file using read Parquet method. And if you see, I'm writing all my select, my filter statements, all such things on this file itself. And I'm just doing a display df, which is displaying in the exact table format which I require. I will save this table if and only if required, which will be used later. But if it's not required, I will not store this table at all. And the data processing and computation will continue on this. And I'll finally just publish a result directly. So this is how a big data application works without ETL. Now that we understood the application doesn't need an internal storage like a database dependency. So you don't have to, so you cannot test by inserting data in a table and fetching it and doing your integration testing. So your application has only a cloud storage and it is a data heavy application. Now for such a system, we'll see how we can go about for the testing of it.
Yeah, thank you, Narmada. So I hope you have learned some about like how a big data application works and how we can like do it without ETL and how we can read the data from external storage. So now let's see how we can test this. So for a big data applications like this, you'll have to perform various number of tests like load, performance, endurance, or like scalability, etc. But here we are going to focus on how do we test this functional wise and how do we automate and what are the challenges while automating this kind of application. So let's start with a simple framework for this approach. So let's say, so first step in this will be to define your test data. Since the Parquet files are not human readable, what you will have to do is you'll have to depend on either some CSV or Excel files to define your test data. So once you define your test data, and our aim here is to test this functional wise. So you don't have to like have a huge data setup for this one. You can pick even a subset of data and you can even define your test data based on your use cases. So once you define your test data in Excel file or CSV file, so the next step will be here. Since your application needs the files in a Parquet file, you will have to write some utilities to convert them to Parquet files, which is available in the Databricks. So once you convert the files using the utilities to Parquet files, you can trigger your applications, which will consume from these files and which will give you the expected output from the system. Now, next step will be in your automation. Of course, you have the expected or the generated data output. You will have to assert on this. And you can write some assertion libraries. But next problem you'll have to solve is you'll have to also generate your expected data. So once you have the expected data, which is again will be calculated using the CSV or the test data you generated, you will have your expected data and your framework is ready now. You can assert on these values. So before going to the challenges, so we will just talk about how we like arrived on this. So when we want to like design a framework for this application or automation, everyone agreed that we don't want to like design a complex system because we are already like building a complex data applications, and same time we don't want to again spend too much time on building an automation framework and spending too much time on maintaining that. So we had like everyone agreed that okay, we want a simple system. So if you see remember the previous framework, the first two steps, basically converting your Parquet file and writing assertion libraries. These will become mostly like constant. You will not have much time effort to spend because only if you are like a schema changes happens in your feed file. Only then you will have to touch on your conversion strategies, how you convert from a CSV to Parquet. Only that time you'll have to touch. And also if any formula changes or any like new tolerances appear, then only you have to touch on your assertion libraries. But why we included this slide here, because to stress on the fourth points. So major challenges you are going to face here is generating your expected data. So going back to our previous examples, like for the payroll calculator. So let's assume your salary hike comes in, basically, which means we are telling a change in reference data. So, or let's say your tax slab changes, which means a change in your formula. And this is going to hugely affect your output. So what happens is like any changes comes, and we know that in a developing environment, these kind of changes are even mostly happens on day-to-day basis. So you will have to keep changing your expected data and you will have to keep maintaining it. So that is the biggest challenges we are going to face while automating these kind of applications. So before going there, Thoughtworks says, please excuse me. So I know that this is going to be very boring stuff for you, but we included this for external people. So this is a general guideline we follow in Thoughtworks while automating any applications. So what this is basically tells you will, when you plan your automation coverage for any applications, have more coverage in your unit layer or bottom layer of pyramid, and plan for your like a less number of tests in the top layer pyramid, which is can be end-to-end or UA. So why? The reason being, it's simple, because you know that the cost of writing an end-to-end test or UI test and maintaining them, it's going to be very huge, because you know that how flaky can be a UI test and how much effort we spend in like fixing them. So if you follow this approach, you can have more coverage in your applications with less effort. Now going back to the challenges which we just touched upon, like how do we generate the expected data and maintain them? So first approach, of course, it's a simple one. We can just hard code the data in a file and which can be fed to our automation framework to ascertain. So if you see the code snippet here, let's see the example, your taxable income. This is an application, or this is an application code which generate your data. And what here you are doing is basically, you are basically like calculating the value manually and giving to the function, which will be then asserted on. So your application will generate a data and you have the manually calculated value to be asserted on. So of course, you know that this is going to be very prone to errors, because the example which we are talking here could be simple because it's having only like a few fields of output. But imagine a system which is having like, let's say 50 or even 100 fields of output. So maintaining this kind of like data, and like every time when a change happens in your formula or reference data, as I said before, it's going to be like very time consuming. So you might end your whole day in fixing these tests only. And of course, we know that we just take the output and we just try to like, okay, just verify on it. And we always have the tendency to like just skip through it. So it's very prone to errors. So definitely we don't want to recommend this kind of approach for applications, big data applications. So what's the next best thing we can do? Yes, write some helper methods, and so that you can even generate your expected data automated fashions. So how we achieve this, or what we do basically here? So you have, let's say, the code snippet. You have again taxable income, which is generated by your applications. So what you do is you feed the same input to your helper methods also, which will kind of like automate your expected data generations. Yes, so this kind of like sounds promising. So you don't have much effort in maintaining this, because any change in your reference data will be automatically handled, because your helper functions is feeding from the same data and you will have the generated data properly. So, and again, if any formula changes comes in, you can easily like change your helper functions, which will be again like reflecting your expected data. But what the problem with this? So here itself, you can see the code snippet. So this is kind of like your actual code base and your helper methods, kind of like using the same code, or it is written in the same language platform. So what we like realized after some point, we started writing a small helper functions, and like as the application grows bigger and complex, we found that almost we are mimicking the dev code in the helper functions also. So basically what it's doing is like you have a system which is generating your output. You have similar kind of code which is generating your expected data, and we are asserting on it. So what we are gaining from here? Maybe we are missing a lot of things, especially the logic we are duplicating, because the code is getting duplicated, and you are writing your helper and your application in the same platform and same language. So you can have like lots of like a platform dependency. One example being, let's take a casting. So any language, like when it's come with like mathematical operations, it has internal castings and it does in a different fashion. So if you have, let's say, if you have set a precision for like 2 for one particular thing, and any operations getting combined with that particular kind of like data, it's again getting trimmed. So you might end up losing your accuracy, and your helper also, which does the same. So basically like you might have errors and you are not catching it. So you don't want to like follow this for like a long time. And next challenge will be portability. So this might not happen in always, but the chances are again like not zero. So let's say like you started with a Databricks, but tomorrow you have to like switch to a Snowflake. So since your test also and helper functions also are written here in the same way, you cannot basically port your test. So if your tech stack changes for your applications, what you have to do end up in completely discarding this test and again like start rewriting your automation test. So you don't have this portability. So how we can solve these two problems? So we don't want to hard code the data. We don't want to again like use so many helper functions to again generate your test data. But again, we want an easy way that we can generate this data and maintaining them as the formula changes or reference data changes happens. So what we did, so we just explored the options and we came up with an generating this data using an Excel. Yes, we know that Excel has lots of inbuilt functions and which can be used for even calculate so many values. But we know that that might not be sufficient because the application is going to have a complex logic. So again, the Excel, the macro enabled Excel, which has extension of XLSM, those we don't know, offers even macros. So what's macros? This is nothing but we can even write, generate, or any complex functions using VB script. Yeah, but the problem again, using a VB script, maybe the old QAs like me who worked in QTP, maybe still have the love towards the VB. But what about the new one? When we explored this option, the answer was kind of no. And again, from the developers, we are working in integrated development environment. Developers were not at all ready to even look into the options of macros or learning VB script because it's not giving much advantage. And definitely again, we don't want to replicate our code base in a VB script fashion. And again, keep efforts in maintaining them. So then what's the next options which we can Excel provides us? So when we or explore the options for Excel, everyone was comfortable to use formulas because that's readily available and you don't have any learning curve or it's very minimal. And you can even use cell reference and everyone was happy to use that. So how we can extend this formula to use complex logic? So Excel again gives two more options for extending your formula basis. You can have a user-defined functions, or even you can have a Lambda functions in Excel. So this is available again in the macro-enabled Excel. So we will learn how we can use these two functions to generate or even handle complex logic in your applications. So this is a Lambda function example. So what this is basically doing, let's say you can define a Lambda functions in the name manager. So what this is basically do is, let's say you have a sum which will go 3 + 2 = 5, but you don't want some other extra logic built into that. So what you can do is you can refer a Lambda functions or create a Lambda functions saying that I want 6 as my output for a sum. So we are creating a sample sum functions here, which takes the input of 2, 3 and gives you an output of 6. So this can be used like any other Excel functions, and you can even use a cell reference, and you can even keep a drag and to keep an update column. So this way, you can have some extra logic built into your Excel sheet, which can be useful for your other calculations. And of course, Lambda functions can't be very complex. Again, you can't have a many, or you might not have the capabilities to have complex logic and loops. So what's the option? Again, we have the user-defined functions. So if you see here, this needs some logic of again knowledge of VB script. But once you define this function, this will be again available in the Excel for everyone to refer. So you don't have to know, you might not have to know about how this function is being written, but you can readily or easily use in your Excel sheet. So what this does is basically, you have this weighted average function which needs some if loops to be checked. So you can write this function and generate this one. And once you generate these functions or write these functions, you can use this in your Excel sheet. So I'll just show you how a sample Excel for our testing application can be. So this is how you can arrange your data. You'll have a main sheet which is generating your output, and you can have, let's say, the reference data in the next sheet. So you can easily refer. If you see here, all this data is being referred from the other sheets, and in the total tags, if you see, we have defined a user-defined functions. And how we can access this? You can go to the developer tab and open the Visual Basic. There is a sample function written here. So this way you can basically what we are doing is extending our code base, or not the code base, the formula base, to have more complex logic. So that's how we were able to solve generating your expected data for a big data applications like this. Of course, and using the Excel had some other extra advantages, because you have all the formulas defined in your sheet. So that was kind of like giving an opportunity for even for others to refer for it. Basically, like BS or PM can open this sheet and see like what's the formula, or if they want to like refer how this particular number is being arrived, they can easily refer the sheet. So which was like readable for everyone. That was commonly accepted in the team. And next one, of course, Excel, you know, like is easy to update because you have like a lots of like drag options. So even if you want to add a new test, you can insert a new row and just drag the formulas. And of course, it has a minimal learning curve. And other advantages being it's portable because you are like defining your system or you are defining your framework and your generated test data outside the system. So even if you are like a tech stack changes, you can easily port this. So you don't have to worry about the losing your effort. This test will be already available for you, and you can easily plug it in your new system. And of course, it's generated in like a different language, so you will not have any issues with the language agnostics problem. So yeah, that's how we are able to like solve the major pain point of our applications in like automating a big data applications like this. Yeah, thank you. The performance numbers you're asking. So basically, like guys, I told we are not like checking any performance on this one. Our idea was to touch base on like how it's functionally works. So if you see here, of course, if you use like a large test data, you have problems like, of course, you have to like pay for that. It needs like lots of computational power. So what we decided here, basically, you will generate or define your test data a small subset. So you will choose your test data, which is required to cover that your application functionally. So which means your test is going to be like very linear. Your system is scanning a very low number of data. So this test will be extremely fast than how the applications work in a general in production.
Yeah, so the numbers that you shared in the slide, right, that had a very big memory comparison that we did. If you try to put Excel in that level of data, then it would definitely slow down all the formulas and all, because if you look at the maximum range in the Excel, which is supported, right, then even if you do for the maximum range, you need a very good laptop for it. So
That's what. So the formula, you will be covering all the small level tests in your unit tests, and only a major end-to-end test case would be sitting in your reference data. You would not put all of your tests into the Excel. You will put only the top part of your pyramid, your last end-to-end layer in this Excel part, which would be a very required subset of tests data. What we saw will be easily handleable, I think, in laptops, right? That data, at least we have used.
Yeah, so again, just want to add like 2 points on that. So I'll tell. So let's say like applications handling with a 1 billion of records normally in productions, and you might need only, let's say, hundreds or even 200 rows in your Excel file, because your aim here is to not to do the performance testing. Your aim here is to do your test application functional wise. But yeah, I get your point. Even if you faced when we started with the more user-defined function, the Excel is going to be like, let's say we had like some maybe 50 extra sheets to refer, and the formulas, of course, it was definitely slowing down. I agree. So that's why like we explore the options of Lambda functions. So the Lambda functions are much performant than the user-defined function. So our recommendation will be, if you are facing like performance issue with the Excel, try to like use maximum inbuilt functions available. If not possible, then just go for the Lambda options next. If at all like you can't cover either like using existing function or Lambda function, then only go for your user defined functions. So but yeah, there will be like little kind of performance, but I think with the current system we didn't face much kind of issues, because the current laptops, of course, it's very powerful, and maybe like we are just taking maybe 10 to 15 seconds for saving in Excel like that.
okay, all right, thank you.
It's just an example. So why we took that example, basically, like we don't want to go into like a complex system. So just for an example, and it can be a payroll system for a big data, but in reality, yes, it might not be like a big, maybe best candidate for like explaining a feature like this. You can even think about some prediction engine, which gives some forecasting. Let's say like you want to run a promotion for your store, and which is generating like a large volume of data. So that can be good example, but we just thought, okay, since payroll will be commonly like used, everyone will be aware of that. Yeah, but I understand.
Yes. A question from Hyderabad. Oh.
Yeah, hello. Can you hear me?
Yeah.
We'll just come back.
One
Hello?
question. One last question. Have you compared Parquet format with the Feather format?
We've not from Parquet, we've moved to Delta, but we've not compared it with Feather.
Okay.
Was there a question from Hyderabad?
Hello. Can you hear me?
Yes.
Yeah,
perfect. So generally Excel sheet, right? So I think the number of records that we can save is limited to a few thousands. So beyond that, we cannot save. Either we need to create a new sheet to continue with storing of records. So as you see, there will be a lot of volumes of data that we need to process in real time in production. I mean, we need to create a lot of sheets in Excel, I believe, which again, creates a maintainability problem, and it consumes a lot of time with respect to the maintenance of it.
So to take our example itself, we gave an example of a 10 lakh employee use case, but that 10 lakh employee doesn't mean we have to store the records for 10 lakh in your Excel for functional test. Your top end of the pyramid is only 10%. And in that, you would, in Excel sheet, you would just keep only the major test cases. Like if you take a tax lab, you would keep only your under 5 lakhs, 5 lakhs, 30 lakhs, and above that. Only these three major things would come into your Excel to form your top layer of the pyramid. It will not be very huge. We can give an example of our application a bit.
So I think I already touched based on this. So the current, the one which we are doing for let's say in the production, it is scanning around 1 billion or more than records. And we were able to like come up with choose our test data because we definitely Excel cannot handle huge complex or like large volumes of data like this. But to functionally cover, do you need all these records? Maybe not. You can like choose your test data. And with the current approach or the one which we are currently following in our project, we had around less than like 200 rows of data. So what that means is like for each row, we'll be testing one particular type of functionality, or even like, let's say your test case is one row. So you can like club more number of like features into one row or few tests. So which that means basically you don't have to like have like a of course, this framework is not for like testing the performance or scalability of your applications. Again, like we are stressing on the point, we want to test the functionality wise. So to test this functionality wise, you can like choose your like data very like diligently, and maybe you'll be able to limit with maybe even like 100 or 200 records. But that's what currently we experienced. But maybe, yeah, I agree that it can like vary from use cases to use cases. And if you are like having or let's say like if you need like more than like 1 lakh test data to test your application functionality, I feel maybe that won't be the case always. But yeah, if at all your use case is demanding that kind of like architecture, yeah, yes, agree. Then Excel might not be a good option for you. You will have to think or like some explore other options. I hope that answers.
Yeah, thank
Sorry,
you.
I think I had one more question.
Example is employee ID or employee name, right? As they said, we have limitation about 64K in the Excel. Okay, I can multiply number of files and then convert those into the Parquet files.
Yes,
That could be possible. Yeah, that way we can handle, I believe.
Yes.
Because smaller chunk of files and then convert into the bulk data in the Parquet file, which can store in the DB.
Yeah, thanks for adding that point. Yeah, that's one of like options. Like you don't have to always like just keeping referring to like one data file. you can have like a number of files defined in your system, and you can convert them using that utilities available, and you can be fed into your system. Yeah, thanks for adding that point.
Are there any questions from any other location?
Hello.
There are multiple frameworks. So for this one, we can use pandas frameworks. So we can write function in this pandas. So it can convert file easily. So I think this will be better option, because I tried many times, function is there, so system is hanging. So I think pandas will be very good option.
Yeah, we haven't explored that option, but yeah, thanks for adding that. Yeah, we'll try to like learn more about that. Thanks.
There was a question from Coimbatore, right?
Yeah.
From Chennai.
So yeah, my question is again related to the choosing of the data set. So basically, is there any specific strategies or techniques you follow to choose the data set?
Yeah, so it's again like as I said, it's going to like vary from use cases to use cases. But you can, let's say like let's going back to the example of, let's say, or the tax calculator. So what you will have basically your payroll calculation. One thing is like your various kind of like income and various kind of bonuses, and the next thing, complex thing, is going to be your tax slabs. So what you can do is for this kind of application, let's say like you just bucket your data or bucket your functionality. How much data is going to come in for this particular functionality, or how I can like get all my bucket or the code coverage using a different rows. So that way, like if you start bucketing your data and like how much functionality you can have, then you can decide maybe to cover 2-3 buckets, I can have just a one row of. So that's what we propose. So start analyzing your application's functionality and the number of or the amount of data coming into your application, and the bucketing of or the basically like how much let's say like how much data comes for a 30% tax slab, or how much data comes for a 10% tax slab. Based on that division, you can like choose your test data.
Okay, thank you.
Are there any questions from Hyderabad or Gurgaon?
Yeah, like from Chennai, I do have one question.
Yeah, please go
So,
ahead.
Am I audible?
Yes.
So the question is, Excel predominantly comes from Microsoft, right? Which is a paid tool. So are there like any other open source or other spreadsheets which can do this?
Yeah, I hope like most of the organization has this Microsoft tool already like available. Yeah, but you can have like other options, but we didn't see much capabilities like Excel with the open source tools. So yeah, so that could be a challenge, but I hope that won't be adding much cost compared to your like big data applications.
Yeah, the primary reason is Thoughtworks have Google spreadsheets, right? So we don't have Excel with this.
Yeah, so you don't have like a macro enabled functionality in Google Spreadsheet, and the functionality and the formulas the Google Spreadsheet is offering is limited. So you cannot have much things automated by using like a Google Spreadsheet. That's why we chose like Microsoft Excel.